Welcome to topic 3403. Case Studies on Emergency Shelter Design for Eco-Resilience. Filling the Gap. Ecological Planning and Design Learning Network and Adaptive Smart Training Module for Disaster-Resilient and Sustainable Cities. We will see learning objectives: Nepal, Earthquake Recovery Shelters, Philippines, Typhoon-Resistant Eco-Shelters, Yogyakarta Earthquake Shelters, Comparative Insights, Summary and reflections in the content of the topic in order. In this session, we are going to learn the experiences of eco-resilient emergency shelter design in different countries, what make them to choose local, sustainable materials and construction methods, and collaborative design and construction processes result in community engagement and ownership of the program. First case study is from Nepal. Hundreds of thousands of people were made homeless by the earthquake that struck Nepal in April 2015. Many families who lost their home needed to build temporary shelters by themselves. But these structures are often very fragile. Using mud bricks are not strong against earthquake and are dangerous because of their weight. In heavy rain conditions, water can easily come inside. Because of that, in earthquake recovery shelters projects they opted for earthquake-resistant, waterproof, inexpensive, local, portable and readily available materials, such as bamboo, stone, tarpaulin and CGI roof prototypes. They organize a Build Nepal strategy. The Build Nepal strategy aims for a long-term, post-earthquake recovery program of 5 years. In this strategy they plan to support include social mobilization, which is empowering communities to join and rebuild. In technical assistance, they were training to provide improved construction skills for safer reconstruction. Tiered assistance, which is providing vulnerable households non-financial support for income-generating activities so that they can build their own capacity, and market development is improving housing value through access to better construction materials and labor. These 4 pillars will uphold an overarching participatory approach and put households and communities in charge of rebuilding their own homes. Volunteer professionals trained the local communities to provide improved construction skills and to have safe houses against disasters. Priority was given to designs that combine safe construction against 2 earthquakes, heavy rains and floods. Water collection and thermal insulation features were added to improve comfort and daily hygiene inside the shelter. The second case study is typhoon-resistant eco-shelters in Philippines. After a disaster, time is critical. Families need shelter immediately, and it is very important for the community to return to normal as soon as possible. In post-typhoon recovery, unlike traditional solution, you have to choose quick deployment to build the shelters immediately. Durability of the shelter structure against strong winds and floods ensures that families don't just get temporary shelters but long-term resilient homes. Typhoon recovery often stretches government and community budgets. Affordable alternatives, cost-effective solutions became important. Eco-friendly approach reduces waste and uses sustainable materials, making it an environmentally conscious option, especially important as climate change worsens disasters. They use materials that are remarkably strong, able to flex gently in high winds, and are lightweight to be transferred easily and cheaply. They searched on both natural and industrial materials available in the local market, such as cocoa lumber, bamboo, sand and gravel, plywood sheathing or prefab and container homes. The key innovative aspect of the shelter design is the strengthening of the structure to enable it to withstand typhoons. Shelter technical design therefore has the following typhoon-resistant features: use of extra bracing and anchoring on wall and ceiling to ensure stability. Metal bracing are stronger than wood bracings. Anchorage tying the roof to the ground through cement footings to achieve continuity. And folding wall panels that pivot open during the day for ventilation and light, then close securely at night. The roofing is layered with woven palm fronds, which is called omicon traditionally. They used CGI sheets or recycled plastic thatch, offering a blend of waterproofing and breathability. They built rainwater storage to meet daily cleaning needs, and also improve hygiene behavior, prevent diarrheal diseases, and encourage community management of water and sanitation facilities. But also using solar lighting for solar-powered lamps to improve security after dark. They built transitional shelters on relocation sites if there is need to transfer the shelters and make minimal impact on the land. Third case study is earthquake shelters in Yogyakarta. This project aimed to empower community members to rebuild their lives, starting with the construction of a transitional shelter. The transitional shelter design was developed through an understanding of locally available materials, community needs and the capacity and objectives of the organization. Community levels of knowledge about the use of bamboo varied. The more urbanized settlements had the lower the level of traditional knowledge in the community. The rural mountainous communities recovered relatively quickly, because locals had worked in the construction industry prior to the earthquake. The volunteers professionals were essential to guide and support construction. This shelter recovery project organized the process with national volunteers, 2 local universities, undergraduate architecture students, a training team, NGO facilitators, trainers, an implementation team, and a bamboo expert. The local universities were involved and helped to develop technical inputs for shelter design and messages, develop posters, pamphlets, t-shirts, etc. Train students to deliver, build back better messages under staff supervision, and set up mobile construction clinics. The shelter program mobilized volunteers as community trainers. Firstly, they made hands-on training making straw models and a mock-up frame, as well as finance training and team-building exercises. Then they worked with communities on selecting and buying materials, the technical aspects of working with bamboo and building the shelters. Working with volunteers allowed a large-scale program. The volunteers were willing to help, but had a low level of confidence or experience. This led to some challenges in ensuring adequate quality control. If we need to evaluate the information we obtained from all 3 case studies, using local materials and labor reduce cost and carbon, collaborative design enhances acceptance, respect, and ease of maintenance, and respect for the environment supports long-term use and sustainability. As a summary and reflections through the topic, we can say that eco-resilient shelters succeed through community ownership. Each recovery requires tailored material, layout, and process choices, and design must evolve with recovery and reconstruction goals according to scenarios.